Welcome to the deep dive. Today, we're tackling a topic that's, well, absolutely foundational for building robust Java applications. And let's be honest, it's something you will get asked about in technical interviews, especially at the senior level.
Yeah.
Java logging frameworks.
That's right. Going beyond just scattering print statements is, step one.
Yeah.
But truly understanding the architecture, how to configure logging effectively, and the trade-offs involved.
Yeah.
That's what demonstrates a senior mindset.
Exactly. So our goal in this deep dive is to take the essential knowledge, the core concepts, the common pitfalls, and sort of translate that into confidence for you so you can discuss logging like you've been doing it professionally for years.
Sounds good.
So let's start where most developers do. The trusty system.out.println. It's great for quick debugging, right? You just sprinkle it in and see what's happening.
It's the universal debugging tool in Java for sure. But as soon as your application grows beyond a simple script, print statements really become a liability. You have no control. You can't easily filter messages by severity. You don't get timestamps or context automatically. And, well, trying to remove them all for a production build is just a nightmare.
Right. So professional logging frameworks solve these problems. They provide structure, context, control. And the key to understanding how they work, something that definitely comes up in interviews, is recognizing the architectural pattern they use, the facade versus the backend.
Yeah, this is a critical concept.
Yeah.
Think of the facade or front end as the part developers write code against. It's the standard API where you basically say, okay, logger, write this message at this level. The platform logging API built right into the JDK is an example of this. It gives you a standard way to interact with logging, regardless of the underlying implementation. Another popular one is SLF4J, the simple logging facade for Java.
Okay, so the facade is the consistent interface you use in your application code. What's the backend then?
The backend is the actual engine that does the work. It receives the log events from the facade and handles all the nitty-gritty, filtering messages based on configured levels, formatting them into text or XML or JSON, and directing them to different output destinations like the console, files, or even across the network.
Okay.
And this backend is typically configured by the people deploying the application, not usually the developers writing the log statements themselves.
Ah, I see. So facade is for the developers writing the code. Backend is for the operators or deployers configuring the system.
Exactly.
Front end for developers, backend for deployers. That's a useful way to remember it. And the big advantage is you can swap out the backend implementation without changing your application code that uses the facade, right?
Precisely. The facade provides that layer of abstraction. You write your code to use the standard facade interface, and then at deployment time, you decide which logging implementation you want to plug in, whether it's the built-in java.util.logging or maybe log4j or logback, which are external libraries, but, offer more features.
And speaking of log4 and logback, while they're feature-rich, they also highlight something really crucial for senior developers: security.
Oh, absolutely.
The log4 shell vulnerability was a pretty stark reminder that the choice and configuration of your logging backend has significant security implications.
Absolutely. Log4Shell exposed just how vulnerable applications can be if logging frameworks have complex internet-facing features enabled by default or, are just configured insecurely.
Yeah.
Understanding that logging is not just about writing messages, but also involves security considerations, choosing robust frameworks, keeping them updated, configuring them securely. That's a key differentiator in an interview.
Yeah.
While a facade can protect you from some backend specifics, the backend choice itself really matters for security.
All right, let's get practical then. If I'm using the platform logging API as my front end, how do I even get a logger instance in my code?
You use the static getLogger method on the system class, so you call system.getLogger and you give it a name. Now, while you can use any name, the common and frankly recommended convention is to use the fully qualified name of the class that's doing the logging, basically. Its package and class name.
So if I'm in a class myApp in package com.mycompany, I'd use com.mycompany.myapp as the name.
Precisely. When you call system.getLogger with a specific name for the first time, the logger gets created. Subsequent calls with that same name just return the existing logger instance.
Right.
So you'd write something like system.logger, logger equals system.getLogger, parcom.mycompany.myapp.
Okay, I have the logger. How do I log? Just a simple message.
You use the log method. You provide the logging level and the message string. For instance, logger.log, system.logger.level.info, application started. That's logging an INFO level message using the log method.
And if I run this with default settings, what does the output typically look like?
Well, the default java.util.logging backend usually formats it quite nicely. You'll typically see a timestamp, the logger name you provided, like com.mycompany.myapp, often the source class and method name too, the logging level itself, info, and then your message. It automatically adds that context, which is way more useful than just a plain print statement.
Definitely. Speaking of levels, the platform API has different levels than the JUL backend, which can be confusing. Can you clarify those levels?
Yes, this is a common point of confusion, and definitely something that might come up in an interview. The platform logging API uses levels like error, warning, info, debug, and trace, listed from most to least severe.
Okay.
Error is the most critical, trace is the most granular,
Yeah.
often used for really detailed debugging. And you can use static imports, by the way, to refer to these just as info, debug, etc., if you want shorter code.
Got it. Now, about logging messages, what if I have a more complex message, maybe including variable data like logger.log, info, processing file plus file name? Doesn't constructing that string happen every single time, even if the info level isn't enabled? That seems kind of inefficient.
You've hit on a classic performance pitfall, especially with those lower levels like debug or trace that might be disabled in production environments.
Right.
Yes. The string concatenation, processing file plus file name, happens first. Then the logging framework checks if the info level is enabled. If it's not, that string you just spent cycles creating is simply discarded. Wasted work.
So how do I avoid that wasted work then?
You use lazy evaluation with a supplier string. Instead of passing the string directly, you pass a lambda expression that produces the string when needed.
Oh, okay.
You call the log method, pass the level like info, and then provide a lambda like process file plus file name. The code inside the lambda of the string concatenation, in this case, only runs if the info level is actually enabled for that logger and its handler.
Okay, so logging an info level message with a supplier for the file name would look like logger.log, info, plusing file plus file name, and that lambda runs only if logging is enabled. That's a really smart way to show performance awareness in an interview, isn't it?
Absolutely. It's definitely an anti-pattern to construct complex strings for messages, especially debug or trace ones that might just get filtered out.
Mm-hmm.
Another crucial use case is logging exceptions. The log method has overload specifically for this. If you catch an IO exception, say in a variable x, you can log it nicely with logger.log. Warning, failed to process file x.
Okay.
This automatically includes the exception stack trace and all its details in the log output. Much cleaner.
Much better than trying to print the stack trace manually, for sure. What about parameterized messages, like maybe username failed login?
Yeah, you can use message format style placeholders for that. You call the log method with a level of format string like user failed login, and then you pass the value for the placeholder, maybe a username variable.
Mm-hmm.
The framework handles the formatting. This is generally safer and often cleaner than manually concatenating strings with variable data.
And internationalization, if I need messages in different languages.
The platform API supports this using resource bundles. You can log a message by providing the level, the resource bundle itself, a key for the message in that bundle, and then any parameters the message needs.
Okay.
Even better, you can associate a default resource bundle when you initially get the logger instance. You just call system.getLogger with both the logger name and the bundle. Then for subsequent log calls, you only need to provide the message key and any parameters.
So the API is pretty flexible then, handles basic messages, exceptions, parameters, localization, and allows for that performance optimization with suppliers. That covers the developer side, the facade.
Pretty much, yes.
Now let's switch gears and talk about the backend configuration, focusing on the default java.util.logging implementation, or JUL as people call it. How do you actually control what JUL does?
All right, so JUL typically uses configuration files, usually named logging.properties. There's a default one in the JDK's conf directory, but for your own application, you'll definitely want to provide your own.
Right.
You tell the JVM where to find your custom file using a system property when you actually start your application.
You mean using the -d flag on the command line, like java-d?
Exactly. You'd use java.util.logging.config.file, path to your logging.properties main class. And the key thing here is that this property is read very, very early in the JVM startup process.
So I can't just set that property programmatically inside my main method using system.setProperty. That seems easier.
That's a classic interview trap. No, you absolutely cannot. Setting java.util.logging.config.file in your main method using system.setProperty has precisely zero effect.
Oh, wow. Okay.
The logging system's log manager reads this property long before your main method even starts executing. Trying to set it programmatically in main is kind of a red flag. It suggests you might not understand how the logging system gets initialized. You must use the .dd flag or configure it differently at startup.
Good to know. Definitely a gotcha. So it's daddy at the command line. How do I actually set logging levels in that logging.properties file?
You can set the level for the root logger, which is sort of the parent of all loggers, using .level info. That leading dot signifies the root.
Okay.
To set a level for a specific logger you created, say our com.mycompany.myapp, you'd add a line like com.mycompany.myapp level warning. Logger names form a hierarchy, like Java packages, and levels generally inherit down that hierarchy unless a child logger explicitly overrides its parent's level.
Okay, hierarchy and inheritance make sense. Now, you mentioned handlers earlier. They're the things that actually output the log messages, right? How do their levels interact with the logger levels we just set in the config?
This is another absolutely crucial concept, and honestly, probably the most common source of confusion and another interview. Gotcha.
Okay.
A message is only actually output if its level is severe enough to pass the threshold of both the logger and the handler it's sent to.
Both.
Yes, both. Loggers pass messages to handlers only if the logger's configured level allows it. Then the handler takes that message and checks its level against its own configured level.
So if my logger for com.mycompany, my app is set to debug in the config, but my console handler is still at its default info level, I won't see the debug messages on the console.
Correct, exactly. The logger lets the ddebug message pass through because its level is ddebug, but the console handler then filters it out because its own level is still info. To see debug messages or trace messages, you must set both the logger level and the handler level to fine, which is the JUL equivalent of debug, or finer, the JUL equivalent of trace, respectively.
Okay, so I need a line like java.util.logging.consolehandler.level fine in the properties file too?
Precisely. You need to configure the handler's level as well. It's a very common anti-pattern to only set the logger level when you're trying to debug granular issues. You'll just be confused why you're not seeing anything.
Okay, that distinction is key. Logger level and handler level must both allow the message through.
Got it. And that ties back to the level name confusion you mentioned earlier between the Platform API and JUL.
Exactly. It adds another layer. The Platform API, the Facade, uses error, warning, info, debug, trace. The default JUL backend maps these internally. Error maps to severe, warning and info stay the same. Debug maps to fine, and trace maps to finer.
Right.
A little memory aid I use. Platform uses plain English levels, while JUL uses its own slightly more Java-specific terms. Confusing these names, especially debug versus fine, is another easy interview mistake.
Good tip. Anything else about the configuration file? Just maybe remember that the properties you set in logging.properties are specific to the logging configuration. They're not general Java system properties that you can access with system.getProperty elsewhere in your code. Don't mix them up in your mind or when you're trying to configure things.
Right, they live in their own world. Okay, handlers. We talked about console handlers sending to system.er by default. What about saving logs to files? That seems essential.
It is essential.
Yeah.
That's handled by the file handler. For any real-world application, you'll almost certainly need this. You can add one programmatically if you need to by creating a new file handler instance and adding it to your logger using logger.addHandler, new file handler.
Okay.
This way, your log messages can go to both the console, if that handler is still configured, and a file.
What does that default file handler do if I just add it like that?
By default, it creates files named something like javon.log, where n is a number 0, 1, 2 in the user's home directory. And interestingly, the default output format is actually XML.
XML?
Yeah. The actual data object being passed around inside the logging system before it gets formatted by a handler is called a log record. It contains a lot of rich detail: the level, the logger name, the raw message before any localization or formatting, any parameters, the exception if one was logged, source class and method names, the timestamp, thread ID, sequence number, quite a bit of info.
How do I configure the file handler? Change the file name, the format, maybe rotation?
You configure file handler using properties in your logging.properties file, or you can set things via its constructors if you're creating it programmatically. Key properties you'll often set include the output level for the handler, whether to append to an existing file or overwrite it on startup, the limit for the maximum file size in bytes, the count for how many rotated log files to keep, and the pattern for the file name.
pattern for the file name, what's that about?
The file name pattern lets you use special variables that the handler replaces when it creates the file. This makes your logging configuration portable across different operating systems.
And that rotation using limit and count is how you prevent logs from just filling up the entire disk, right?
Exactly. That's crucial for production. You set a maximum size limit, often in bytes, and how many old versions to keep in. When the current file, say myappy0.log, reaches the limit, it gets renamed by incrementing the generation number. Myappy0.log becomes myappy1.log, myappynp1.log becomes myappy2.log, etc. And a new empty file, myappy0.log, is created. The oldest file, myappy.log, if it exists, gets deleted to keep the total number of files within the specified count. This is absolutely non-negotiable for production systems.
Makes sense. What if I need even more control? Like maybe custom filtering logic that goes beyond just the log level, or maybe I want a different output format like JSON.
Yeah, that's where custom filters and formatters come into play.
Yeah.
You can create your own class that implements the java.util.logging.filter interface.
Yeah.
It has just one method you need to implement, is loggable, which takes a full log record and returns true if the message should be processed by the handler, or false if it should be discarded.
Okay.
This lets you add pretty much arbitrary filtering logic. Maybe you only want to log messages from specific threads, or messages containing certain keywords, whatever you need beyond just the level. You configure a handler to use your custom filter in the login.properties file by setting its filter property to the fully qualified class name of your filter.
And formatters for changing the actual output structure.
Right. A formatter defines how that rich log record data is turned into the final output string or bytes that get written to the console or file. You extend the java.u2.logging.formatter class and override the format method. This method also receives the log record. Inside your custom format method, you can access all the details in the log record, the level, the message, parameters, source info, time, thread ID, everything we mentioned. You can use this to create literally any output format you need. Maybe a specific compact text format, or maybe JSON, which is increasingly popular for feeding logs into centralized analysis systems like Splunk or Elasticsearch.
And you configure that the same way in the properties file?
Yep, exactly the same way as a filter. You set the handler's formatter property to the fully qualified class name of your custom formatter, like java.util.logging.filehandler.formatter.com.mycompany.myapp.myJSON formatter.
So thinking about production really means nailing down the handlers, especially file handler with proper rotation and append mode, being really mindful of performance with levels and using lazy evaluation, and knowing you can extend the system with custom filters or formatters for integration or advanced logic if needed.
Precisely. Understanding these configuration and customization points shows you're thinking about how the application behaves in a real-world, potentially high-volume environment. That's key for demonstrating senior-level thinking.
All right, let's wrap this up and bring it back squarely to the interview setting. We've covered quite a bit from the core architecture to basic usage, deep into configuration and customization. How does knowing all this really prepare someone for that senior Java interview?
Well, it starts with those fundamental concepts, doesn't it? Can you clearly explain the facade versus backend pattern and why it's beneficial? That shows you understand good design principles, abstraction.
Yeah.
Can you discuss how to configure logging via the logging.properties file and the crucial -d flag? That shows operational awareness, knowing how things actually get set up.
And knowing the difference between logger levels and handler levels feels critical for any debugging conversation.
Absolutely critical. Being able to explain why you need to set both levels to see debug messages demonstrates practical, hands-on debugging knowledge.
Right.
It shows you've likely done it. Using lazy evaluation with suppliers shows performance consciousness. Talking about file handler configuration, rotation, limits, patterns shows you think about system resources, stability, deployment considerations. And knowing about custom filters and formatters shows you understand how to extend standard frameworks to meet potentially complex enterprise requirements.
Let's do a really quick recap of those interview gotchas or red flags, the things to definitely avoid saying or doing that might signal a lack of experience or understanding.
Okay, quick checklist rundown. First, never suggest system.out.println for production logging. Just don't.
All right.
Second, do not try to set the java.util.logging.config.file system property programmatically inside your main method. Remember, it won't work. Show you know it needs the -d flag. Third, be crystal clear on the level mapping between the platform API, debug trace, and JUL. Fine, finer, severe. Don't mix them up.
Okay.
Fourth, understand and be able to explain that you must set both the logger level and the handler level to actually see messages at a specific granularity like debug or trace.
Group.
Fifth, Avoid manual string concatenation for log messages, especially debug trace that might be filtered out. Champion suppliers or parameterized logging for efficiency. Sixth, don't confuse logging configuration properties in logging.properties with general Java system properties accessed via system.get property. They're separate.
Got it.
And finally, show awareness of logging security concerns. Mentioning log4 shell, even briefly, shows you're paying attention to real-world issues.
So avoiding those common anti-patterns and, just as importantly, confidently explaining the concepts we've discussed, the architecture, configuration, the nuances of levels and handlers, performance, customization, that's really how you demonstrate that senior level understanding of building and managing robust systems. The goal is to feel comfortable explaining the why and how behind these logging components.
Exactly. It's about showing you've moved beyond just writing code to understanding how it operates and how to manage it effectively.
And that brings us to the end of this deep dive into Java logging frameworks.
It's definitely a topic that might seem simple on the surface, but as we've seen, it has surprising depth that's really crucial for building and maintaining real applications effectively.
Absolutely. And when you think about what's possible with custom formatters turning those log records into structured data streams, here's a thought to leave you with. With logging potentially becoming this rich stream of structured data, how would you leverage that data stream not just for debugging, but maybe to monitor your application's health and potentially predict issues before they cause a major outage?
Ooh, that's a great question to ponder. We definitely encourage you to revisit these concepts, maybe play around with a login.properties file yourself, or even try implementing a simple custom handler or formatter. That hands-on experimentation is really key to solidifying this knowledge.
Definitely. And if you found this deep dive helpful in building your confidence for those technical discussions, please do let us know.
Yeah, give us a like, subscribe to the channel if you haven't already, and maybe drop a comment below with your own logging questions, or perhaps share a tricky logging scenario you've faced, or even an interview question about logging you were asked. We love hearing from you and going on these deep dives together.